Hi, my name is Anis Safia binti Al-Faiza. So, for the introduction, floating steady, a simple look at metacentric height. So, when it comes to keeping things upright to water, it's not just a chance, it's physics doing its jobs behind the scenes. One key idea is metacentric height, or known as GM, which is the distance between a floating object's center of gravity and its metacenter. The bigger this distance, the better the object can resist tipping over. So, whether you're building the ship or analyzing a floating platform, understanding GM helps explain why some objects stay balanced even when water gets a little choppy.
Hi, my name is Devarasan Lakithyagarajan and my matrix number is CN240409. Now we will be looking at the theory. When an object floats, its stability depends on the relationship between its center of gravity, G, where its weight is concentrated, and its center of buoyancy, B, the center of the displaced water. If you tilt the object, B shifts sideways, while G stays fixed, creating a turning effect. The metacenter M, an imaginary point above buoyancy, determines stability. If the metacenter is higher than gravity, the object will right itself, stable. If metacenter is below gravity, it will capsize, unstable. The distance between gravity and metacenter, which is called the metacentric height, measures how stable the object is. Greater distance means more stability. The principle explains why wide, flat-bottom boats are more stable than narrow ones, and why loading weight too high makes vessels prone to tipping. Engineers use these concepts to design ship and floating structures that can withstand waves and shifting loads without overturning. These figures here shows the stability in an immersed body. Now we will be looking at the formulas that we will be using to calculate the results for our lab work. First equation is overturning couple CO, which is equals to mgx. The second equation is righting couple CR, which is equals to mg open bracket gm close bracket tangent angle. For equilibrium condition, CO is equals to CR, then GM equals to WX over W tangent angle. And then the results obtained from the experiments can be compared with the calculation method. Calculation using area of second moment as follows. Equation 4 will be BM is equals to I over V, which I is equals to the following here. And GM is equals to BM minus BG, where equals to BM minus Y plus D over 2.
Assalamualaikum, my name is Amir Hani binti Arman and I will be explaining about our methods that we use to carry on the experiment. For our step 1, we will be removing the horizontal weight and fix the height of the vertical weight on the mass of pontoon. And the step 2, we will be determine the center of gravity, which is CG, by putting the pontoon mass on the pontoon stabilizer, measure the CG, which is the half distance from the base of pontoon to the center of the vertical weight. And for our step 3 is we will be fixing the horizontal weight and ensure that the thread is at 0 mm position with no tilting. Next, for the part 2, step 4, we will be filling the tank with water and place the pontoon in the tank. And for our step 5, we will be measure the length of the pontoon, which is submerged in the water. And step 6, we will be move the horizontal weight, which is to 10 mm to the right, and record the angle of tilting of the thread. For our methodology part 3, step 7, we will be repeating step 6 by moving the horizontal weight to the right with 10 mm increment. Record the angle of the tilt and repeat this step until the weight hanging on the thread touch the side of the pontoon. Step 8, we will be repeating step 6 and 7 by moving the horizontal weight this time to the left side. And for our step 9, we will be adjusting the height of the vertical weight to new height and repeat step 1 to 3 and step 5 to 8. Do this test for 2 different sets of values, of the vertical heights to get our desired results.
Hi and Assalamualaikum. My name is Amirul Haziq and my matrix number is CN240169. Today I want to explain about the results and discussion of open-ended lab. Alright. This shows about the about the test 1. Okay. Test 1 showed the least stable behavior due to the high center of gravity. When titled right, the GM values range from 8.11 mm to 29.96 mm, with stability improving at smaller angles. Left tilts produce similar GM values but required more force to tilt, suggesting the high CG made the body initially resistant to movement. However, once titled beyond 50 degrees, the stability decreased significantly, showing this configuration is vulnerable to capsizing at larger angles. The similar right-left results indicate symmetrical stability characteristics at this CG height. Okay, next is test 2 showed improved stability over the test 1. Right tilts give GM values from 12.80 mm to 76.94 mm, demonstrating much better stability at smaller angles. Left tilts showed even higher stability, with the 14 degrees tilt producing the highest GM value of all tests. This configuration proved most stable at moderate angles between 15 to 45 degrees, making it suitable for applications expecting regular control disturbances. The increased left side stability suggests possible weight distribution effects worth further study. Alright, for the last part of discussion is the test 3 showed excellent performance across all angles. Right tilts produce GM values from 51.96 mm to 124.77 mm, with stability increasing dramatically at angles below than 30 degrees. Left tilts maintain strong stability, though slightly less than right tilts at equivalent angles. The 10 degrees right tilt achieved the highest GM, which is 124.77 mm, proving this configuration resists small disturbances exceptionally well. These results confirm that lowering the CG significantly improves the stability while maintaining good symmetry between left and right tilting responses.
Last but not least was the conclusion. This experiment successfully demonstrates how the position of the metacenter M relative to the center of the gravity G determines the stability of a floating body. When the metacenter is above the center of gravity, the body is stable. On the other hand, if the metacenter falls below the gravity of gravity, Gm more bigger than O, instability occurs. The greater the metacentric height, the better the object resists tipping. In short, the larger GM, the smoother sailing. That's all from us. Thank you.